Imagine a mountain 6 miles wide, hurtling through the blackness of space at 40,000 miles per hour. It has a destination, Earth. In the next 24 hours, our world will change forever. So, what would that day actually look like? This isn't science fiction. By studying the scars left by ancient impacts, like the Chicxulub crater from the asteroid that wiped out the dinosaurs, scientists have pieced together a terrifyingly clear picture. What unfolds when our planet is in the crosshairs isn't just one disaster, it's a cascade of destruction. A planetary reset button pushed with unimaginable force. It begins not with a bang, but with a silent, ominous arrival. For our scenario, let's picture an asteroid about 10 kilometers or 6 miles wide, roughly the same scale as the dinosaur-killing Chicxulub impactor. In its final hours, it would become visible to the naked eye. First, a star-like point of light that isn't on any charts, then growing unnervingly bright until it outshines everything in the sky. As it hits the upper atmosphere, the countdown enters its last, terrifying seconds. The asteroid shoves the air in front of it so violently that it literally carves a temporary hole in the atmosphere. Friction heats it not into a gentle streak like a shooting star, but into a blinding white-hot star falling to Earth. For anyone at ground zero, this is the last thing they'd ever see. The light is blinding, the air itself turning into superheated plasma. The impact lasts less than a second, but in that fraction of a second, it unleashes the energy of an estimated 100 million megatons of TNT. That's billions of times the power of the bomb dropped on Hiroshima, and thousands of times the entire world's nuclear arsenal combined. It's an energy release so vast, it's hard to wrap your head around. In that moment, the laws of geology are broken. The moment of contact is completely silent. Sound simply can't keep up. The first thing that happens is the creation of a massive cavity in the Earth's crust. This isn't your average crater. It's a transient wound, opening up 100 kilometers, 62 miles wide, and 30 kilometers, 19 miles deep, in a matter of seconds. Rock that has been dormant for millions of years is instantly vaporized or melted and thrown upwards in a colossal plume. That plume, carrying up to 25 trillion metric tons of Earth, punches straight through the atmosphere and into space, with some of it reaching temperatures hotter than the surface of the sun. Then gravity takes over. The impossibly deep cavity collapses back on itself. The center rebounds, creating a peak ring of mountains, a feature we see in the buried Chicxulub crater, as rock from deep in the crust is violently thrust upwards. The entire event triggers a mega-earthquake, estimated at a magnitude 10 or 11, unleashing 50,000 times more energy than the devastating 2004 Sumatra earthquake. These seismic waves ripple across the planet, shaking the entire globe for weeks or even months. Within the first few minutes, the primary killer for hundreds of miles around isn't the rock, but the air itself. A superheated fireball of plasma expands from ground zero, creating winds far exceeding 1,000 kilometers per hour, over 620 miles per hour. This isn't just wind. It's a pressure pulse that scours the landscape clean, shredding everything in its path and instantly killing any life. An area the size of a large country is simply obliterated, but the destruction goes global. As that plume of vaporized rock and debris falls back to Earth, the particles, called spherules, re-enter the atmosphere all over the planet and heat up like trillions of tiny meteors. This turns the sky into a global broiler. The atmosphere fills with so much infrared radiation that it heats the ground to the point of ignition. Within an hour, this process begins to trigger worldwide wildfires. Scientists estimate the Chicxulub impact may have ignited nearly 70% of the planet's forests. Any creature not sheltered in a deep burrow or underwater would be cooked by a sky that is turned into a radiant heat lamp. Since water covers over 70% of Earth, our asteroid is most likely to strike an ocean. The impact doesn't just create a splash, it displaces a colossal amount of water, generating a mega tsunami on an unimaginable scale. Simulations based on the Chicxulub impact, which hit a shallow sea, show what comes next. Just 10 minutes after impact, a ring-shaped tsunami, estimated to be a staggering 1.5 kilometers, nearly a mile high, begins to sweep across the ocean. This initial wave has up to 30,000 times more energy than the 2004 Indian Ocean tsunami, one of the deadliest in recorded history. Over the next few hours, this wave travels at the speed of a jetliner. It doesn't just hit coastlines, it swallows them whole, sweeping inland for hundreds of miles. Within 24 hours, virtually no coastline in the world would be left untouched. Even shores thousands of miles away would be slammed by waves tens of meters high. While fires rage and tsunamis reshape the world's coastlines, a more sinister threat begins to unfold. The incredible amount of dust, soot from the global fires, and sulfur aerosols from vaporized rock starts to cloak the planet. If the impact hits a sulfur-rich area, like the Yucatan Peninsula, it's even more catastrophic, spewing hundreds of billions of tons of sulfur into the stratosphere. This creates a thick, dark shroud that envelops the globe. Sunlight, the source of almost all life's energy, is choked off. Within the first 24 hours, day turns into a freezing, perpetual twilight. Temperatures plummet, kicking off an impact winter that could last for a decade. The very chemistry of the atmosphere is rewritten. The vaporized sulfur mixes with water to form sulfuric acid, which falls as devastating acid rain. The oceans, the cradle of life, begin to acidify. Photosynthesis grinds to a halt on land and in the sea, causing the base of the global food chain to collapse almost instantly. In these first 24 hours, survival would be a lottery of location. Anyone within the blast and firestorm zone, a radius of hundreds, if not thousands of miles, would perish instantly. Those on the coasts would face the unstoppable megatsunami. For the survivors, the world would be unrecognizable. The sky would be dark, the air thick with dust and smoke, and the ground constantly trembling with aftershocks. The immediate challenge would be finding breathable air and shelter from the acid rain and plunging temperatures. Our complex, interconnected civilization, power grids, communication, transport would simply cease to exist. All that's left is a fight for survival in a world that has been violently and fundamentally broken. The first 24 hours are just the start of one era's end and the violent birth of another. The impact winter, acid rain, and the collapse of the food chains would continue for years, leading to a mass extinction event that would set life on Earth back millions of years. And yet, as terrifying as this is, it's a powerful reminder of our planet's place in the cosmos. It also highlights the critical importance of planetary defense. Today, scientists are actively tracking thousands of near-Earth asteroids. And for the first time in history, we've proven we can fight back. In 2022, NASA's DART mission successfully slammed a spacecraft into the asteroid moonlet Dimorphos, altering its orbit. This test was a monumental success, showing that with enough warning, we can deflect a hazardous object. It proved that the fate of the dinosaurs doesn't have to be our own. The story of an asteroid impact is one of destruction, but it's also becoming a story of human resilience and ingenuity. If you want to explore more incredible what-if scenarios grounded in real science, make sure to subscribe and hit that notification bell. What other cosmic event should we explore next? A nearby supernova, a rogue black hole, Let us know in the comments below. Thank you for watching. I really would appreciate it if you would subscribe, follow, like, and comment, as this helps the algorithm know that people are interested in my videos.